Section 6.1, Confidence Intervals for the Mean, Large Samples. So for this section, we are going to find a point estimate and a margin of error, construct and interpret confidence intervals for the population mean, determine the minimum sample size required when estimating mu. A point estimate is a single value estimate for a population parameter. For this section, we are doing about the mean for large samples, so mean is going to be our point estimate, or mu. The most unbiased point estimate of the population mean mu is the sample mean x bar. So the estimate for the population parameter is mu, but with the sample statistic, it is x bar. We are going to use x bar to infer upon mu for the population parameter. Level of confidence, or C, the probability that the interval estimate contains the population parameter. So this is C. So what is left over from C is what we call alpha. So this with this, the white parts are alpha. So if I wanted to find these parts that are now yellow, could I not say that 1 minus C divided by 2 would give me these? Which would be the same thing as saying 1/2 1 minus C. But also I told you that 1 minus C is alpha, so this could be also alpha divided by 2 and alpha divided by 2. We can use the standard normal table to find the corresponding z-scores, or we can use Excel norm.s.inverse 1 minus c over 2, or we can replace that 1 minus c with alpha. If the level of confidence is 90%, this means that we are 90% confident that the interval contains the population mean, mu. So if that's 90%, we take what's remaining, 10%, divide it by 2, get 0.05, 0.05. If we were to put this into technology or into the table, we would get 1.645 as our z-score. Sampling error. Sampling error is the difference between the point estimate and the actual population parameter. So it is simply x bar minus mu, which makes sense because this x bar is in our sample, mu is our population parameter. So if we subtract those two, we would find the sampling error that existed in the sample. Mu is generally unknown. X bar varies from sample to sample. Margin of error is the greatest possible distance between the point estimate and the value of the parameter. It is estimating for a given level of confidence C. So the margin of error is denoted by E equals the z-score times sigma with respect to x bar, or you could write it as z-score times sigma divided by the square root of n. Either way is fine. These are for when n is greater than or equal to 30. And this is our error. We are going to be taking this, plugging in the z-score that we just found, multiplying it by these values, and then we're going to add and subtract it to mu to find what we are really trying to figure out, which is the confidence interval. But I will review all of that as the PowerPoint goes on. Sometimes this is called the maximum error or estimate of error tolerance. So the confidence intervals for the population mean is, as I told you, mu's in the middle. We're going to subtract the error from the mean we found in the sample, x bar, and we're going to add it to the mean we found in the sample, x bar. And that is going to give us our interval for the population mean, mu. And this again is a reminder of what the error formula actually is. The probability that the confidence interval contains mu is C. And as I told you, C is going to be probably given in most of the problems that we have. And it's going to be something around 90%, 95%, 97.5%, 85%, all of these different numbers. When you're finding a confidence interval for a population mean, when it is greater than or equal to 30, these are the steps you're going to take and the words that I'm going to use, and then the symbols associated with it. So first, you're going to need to find x bar, which you can do it with the formula, or you can use the average function in Excel. Then you need to specify if sigma is known. All right, estimate for sigma. In order to estimate for sigma, we're going to have to find the standard deviation, S. This is the formula you could use, or you could use stdev.s in Excel. Next, we need to find the critical value, which is the z-score that corresponds to the given level of confidence. And like I discussed, we're going to use the table or norm.s.inverse 1 minus c divided by 2. Now I discussed earlier that 1 minus c is alpha, so if you don't want to do 1 minus c, you just do alpha divided by 2. So what if c was 0.95? This would be 1 minus 0.95. So what is that? That's 0.05. So you don't have to put the 1 minus is what I'm telling you. You could just put 0.05 divided by 2, or you can do 1 minus 0.95 divided by 2, and you will get the same result. To find the margin of error, we plug the z-score we found in 3 in with the standard deviation we found in step 2 and divide it by the square root of n that is given in the problem. Then we find the left and the right endpoints and form the confidence interval. So we subtract e from x bar that we found in step 1 and we add e to x bar that we found in step 1. And then we are given our interval. Once we are given all this information, we need to interpret our results. So that brings us, how do we interpret this interval? Interpreting the results, mu is a fixed number. It is either in the confidence interval or not. It is incorrect to say that it is 90% probable that the actual mean is in this interval. We don't really know that, but what we can say is if a large number of samples are collected and the confidence interval is created, approximately 90 of these intervals will contain mu. So we're going to collect a lot of these samples. As you can notice, here are all the different samples that we could collect. And what we're saying is 90% of the time mu will be in there. So as you notice, it's not in this one, but that's okay. So the one that is not containing mu, that's okay because we're only containing 90% of mu. Alright, a social networking website allows its users to add friends, send messages, and update their personal profiles. The following represents a random sample of the number of friends for 40 users of the website. Find a point estimate for the population mean, mu. So I've already typed this stuff into Excel, and I have it right here. So the first thing that asks me for is to find the population mean mu. So in C1, I'm just going to write mean. And then next to that, in D1, I'm going to go to my function wizard, and I'm going to go to average, and I'm going to use that function, and I'm going to find the average of all my data points. So in my Excel, it is A1, if I can type this in right, A1 through A40. And I'm going to hit enter. And I see that my mean is 130.8. Now if I go back to my PowerPoint on the next slide, it shows X bar being the mean as 130.8 as well as I did, so you can use either the formula or Excel to find this value. Now let's find the margin of error. Now there's not a little special function I can type in, so we're going to have to actually use the formula that was found. We need to know the mean, 130.8. We need to know 95% confidence, the fact that there's 40 users, and that the standard deviation is 53. So I'm going to write all that information down because I find it valuable to do that. So n equals 40, s equals 53. It says sample standard deviation. And we know that C equals 0.95. Alright, so now the error formula, first I need to find the critical value. So in order to do the error formula, there's one thing I don't have because the error formula is error equals z-score times s divided by the square root of n. So we have n, we have s, but we don't have z. So we need to find a z-score that's corresponding to 0.95. Now we could do that by using, if I can spell score right, z-score. We can do that by using norm.s.div. So I'm just equals norm.s.inv, not dist, and I'm going to type in what I had told you. I can do 1 minus alpha divided by 2. 1 minus c divided by 2 or alpha divided by 2. So I'm going to put 0.05 divided by 2. That's going to be a negative number. So I want the positive number, so I'm going to go back to my formula and I'm going to do a 1 minus in front of it. That way I can get the positive value because that's the one that I want to plug into my equation. So you could also use the table to find that. So first you would find the critical values. So let's look back at the PowerPoint. I just showed you how to do it in Excel. When we're looking at it, the critical value C here is 0.95, and then 0.05 divided by 2 is 0.25 on either side. So I can use table, I can use Excel, and I find that 1.96 value. Now we can use that information to plug it into the error formula. So I have error equals z-score times s divided by the square root of n. And as you can see on the PowerPoint, I've done that. 1.96 times 53 divided by the square root of 40. So in with Excel, I'm just going to have to type those numbers. Equals 1.96 times parenthesis 53 divided by SQRT of 40, and then close the parenthesis and close it again. That's going to give me the same thing that they found in the PowerPoint, 16.4. That is for my 95% confidence interval. Now, what we need to do is we need to take that 16.4 that we found, we need to add it and subtract it to our mean, which we found to be 130.8. So the left point, I'm going to subtract it, and I get 130.8 minus 16.4, which is 114.4. On the right-hand side, I'm going to add it, 130.8 plus 16.4. That gives me 147.2. And then now I have created my interval with those two things. So I know 95% of the intervals will contain mu. With 95% confidence, you can say that the population mean number of friends is between 114.4 and 147.2. And that is how you construct a confidence interval about the mean of a large sample. Alright, so here we have another one. Constructing a confidence interval, sigma, when it's known. So it tells me that in a random sample of 20 students, the mean age to be found is 22.9. From the past studies, the standard deviation is known to be 1.5. So we don't have to find mean or standard deviation. They have given that to us, and they have also given us the amount of people that have involved with it. They want a 90%, my mistake, 90% confidence interval for the population mean age. So first thing, I figure out what is my right-hand side. So I have 90%. So what's left over from that is 1 minus 0.10 and divide by 2. So that gives me the area that I can type into norm.s.inverse, which will give me a z-score of 1.645. Once I get that 1.645, I can plug it to the error formula and continue moving with the problem. So it's 1.645 times 1.5 divided by the square root of 20, which was all given to me in the problem. That means our margin of error is 0.6. Once we find the margin of error, we need to put that into the interval formula, subtract it from the left, add it to the right, and we get an interval of 22.3 less than mu less than 23.5. So with 90% confidence, you can say that between the mean age of all students is between 22.3 and 23.5 years. Now, most of our problems have given us n, but some problems are not going to give us n, and we're going to have to figure out n in order to have a certain margin of error. So if sigma is unknown, you can estimate it using S, provided you have a preliminary sample with at least 30 members. So you want to estimate the mean number of friends for all users of the website. How many users must be included in the sample if you want 95% confidence? So assume the sample standard deviation is 53. It wants it within 7 friends. That means the 7 friends is our error. So then we plug it into the formula. We have to first find the z-scores of 1.96. And then plug it into the newly revised formula, which was just solving the error formula for n. So I know my z-score is 1.96 times my standard deviation, which is S, 53.0, divided by my error, which was 7. And then I'm going to square it. That gives me 220.23. Now, we were talking about friends. And anytime you're trying to figure out an n where you need at least this amount of people, you just always want to round up. So 221. All right, that is section 6.1 summary. We found a point estimate, which was our mean. We found a margin of error using the formula, constructed and interpreted the confidence intervals, and determined the minimum sample size required when estimating mu. So here's just a little summary here. The parameter was mu. The description was a normal, standard normal, in fact, and it was norm.s.disc 1 minus c divided by 2, or you could use norm.s.disc 1 minus alpha divided by 2.